All right, welcome to Lab 2, Lines of Charge. This is by me, Chandler Pittman. A little bit about our table of constants today. First, we have our introductions. This will be the equations and experiment as a whole. Next, we'll kind of get into the model, what I coded in VPython. Third, we'll get into the calculations that I did by hand to kind of get some of these values. And fourth, we'll get into our analysis and conclusion. So first, for our introduction. As you can see, here are some of the equations we used during the lab. The first three, the electric force, the electric field, and the gravitational force constant, were all used in Lab 1. However, for Lab 2, we introduced a new equation, which would be the electric field of a charged rod, as can be seen on the far right. So our experiment is the same as Lab 1, same as last time. First, we started with a single U-tape. We created the U-tape and a base tape that was put on the table, ripped off that U-tape off of the base tape to give it non-zero charge. We then compared the U-tape to a finger and pin and said, is a U-tape positively or negatively charged? We found that it was attracted towards the finger when non-zero charged, attracted to a neutral pin or opposite, and it repels the same charge. And then when it came to our U-tape interactions, we created a second U-tape to compare it to first U-tape. We found that when U-tapes are put near each other, they have the same charge, so they repelled from each other. If either tape had different charge, then they would have been brought together. So a little bit more about the results we saw from our experiment. I kind of mentioned this briefly on the slide before, but a little about the results. First, U-tape was attracted to our fingers as well as other random objects, such as maybe a water bottle or a pencil. U-tape was attracted to a pin that was negatively charged. U-tapes repelled each other when they were put close together. And finally, U-tapes are positively charged and they lost electrons. So now, let's kind of get into the model that we used throughout this lab. So first, as you can see, this is our model. A bunch of different fill-in-the-blanks for our different VPython code. Up top is just our basic electric field equation, and then in the bottom is kind of our function that we use to, iterate through each piece of charge in the top tape, and then kind of calculate the electric field at the location of the top tape and the electric force of the top tape due to the bottom tape. And then we also create an error for the net electric force at the top tape due to the bottom tape. So after that model's kind of run, this is what we can kind of see from that. You can see there's two main arrows, the two forces, the electric force and the gravitational force, as well as kind of the electric force of the tape that we can see there. Now getting to a little bit of the calculations I did. So on the top left, you can see my different measurements that I made throughout the experiment. First being the distance, the tapes were the separation distance, the mass of the tape, the length of the tape, and the width of the tape. And on the right, you can see the two different calculations that we're kind of focusing on in this lab. So the first calculation on the right would be for just an electric point charge rather than doing a line charge. And then this bottom one is that line charge model. And now let's get into a little bit of analysis and conclusion. So a little bit about our analysis and conclusion. For some assumptions and meaning, we assumed that each piece of tape had an exactly equal charge and that there was an even distribution of electrons and atoms throughout. As well as throughout the experiment, we were able to determine attraction and repulsion interactions between the tape and other objects. So like I said earlier, U-tape being attracted towards the finger when it was non-zero charge and attracted to a neutral pin or opposite pin. However, it would always repel the same charge. We also kind of made some assumptions. We ignored air resistance as well as sometimes we treat it as a point charge when we were doing point charge calculations. And then finally, when it kind of comes to some sources of error that we could have kind of run into, first would be human error. So this would be incorrect observations in touching the tape. Some induced charge error, objects near tape becoming polarized, which would affect the electric field. Changing charges error, so pulling tape of a surface may not transfer charge uniformly. And environmental error, which is different surfaces, bad contact, surface material, or the stickiness of tape could have all affected that. And so when we kind of wrap it all together, we see what are we trying to figure out and why. So when it comes to the question, what if you had modeled each of your tapes as a single point charge like in the previous lab, we could compare the estimated value of the charge you got when you use your experimental data to produce a point charge model to the value you got with your line charge model. So if I had modeled each of my tapes as a single point charge, I would have gotten the charge on each tape to be 2.04 times 10 to the negative 8 coulombs, whereas if that'd be much different than the line charge model where I got 3.64 times 10 to the negative 8 coulombs. And then finally, why do these estimates differ, and which value is more likely to be closer to the real value and why? Like I said previously, these estimates are different because they have different electric fields and charges are spread out differently throughout the tape. So line charge model is more like the real value because it matches how an electric tape would actually be. Rather than being a single point charge, it'd be a line charge across the whole tape. And yeah, that's all I have today. Thank you.